In this video, we are going to be looking at some vocab terms and defining and understanding the differences between some of these words that we're going to be using throughout the year. So the first thing we're going to look at here is the difference between an element and a compound. And so elements are going to be defined as pure substances made up of the same type of atom. When we think of chemical substances that are made up of the same type of atom, right? Generally, when we're talking about elements, we're going to be talking about something that's coming from the periodic table of elements. So if we're talking about a single element, for example, carbon or fluorine or helium, there we're talking about all atoms of those individual elements, and therefore we're talking about just the single element. Whereas when we're talking about a compound, we're talking about how compounds contain different elements or contain atoms of different elements. And we're going to see in just a minute that those different elements are always going to come in a fixed whole number ratio, and we're going to talk about what that means. But when we look at the difference between an element versus a compound, the big thing I want you realizing is that compounds are made up of two or more types of elements. So we look at water, we see hydrogen, which would be an element, and we see oxygen, which would be an element. We look at ammonia, we see nitrogen and hydrogen as well. So compounds have two or more types of elements, whereas the element itself is just the single type of atom. So when we think about elements and compounds, it's important for us to think about these two laws because these two laws help us understand how we have so many different compounds that exist. And so the first thing we're going to talk about is this idea of the law of multiple proportions. And this law states that elements can combine in different whole number, that looked like a D, different whole number ratios to form different compounds. And what do I mean by this? So a compound that we are all very familiar with is H2O. And this is the formula for water. And in this formula, we have 2 hydrogens for every 1 oxygen. That's the ratio. It's a 2-to-1 ratio for hydrogen to oxygen. But hydrogen and oxygen aren't always going to combine in this ratio. They could combine in different ratios with each other. They could combine with other elements. So an example of this would be H2O2. And this is what we call hydrogen peroxide. And you may have heard of this one. This is most likely going to be found in your bathroom. So hydrogen peroxide has a different whole number ratio of hydrogen to oxygen. Here we're looking at 2 hydrogens to every 2 oxygens. So the law of multiple proportions is the idea that these elements are not stuck to combine with one another in just that one known ratio. They could combine in different ratios, and that when they combine in different ratios, they are going to form different compounds. Left that part off there. They're going to form different compounds. But that also leads us to this law of definite composition. So in the law of definite composition, we know that a given compound is always going to contain the same number or the same ratio of elements. So water is always going to be H2O. Hydrogen peroxide is always going to be H2O2. whenever I change the ratio of the elements in the compound, I've changed the compound itself. So the next thing we're going to look at is the difference between what we call a pure substance versus mixtures. So pure substances are going to include elements and compounds, and they are things that cannot be physically divided or physically separated. Whereas mixtures are things that can be physically separated. And there are two different types of mixtures that we're going to look at next. So there are two types of mixtures that we're going to be learning about. We have homogeneous mixtures and heterogeneous mixtures. The difference between these two words comes from the prefixes at the beginning. So this prefix homo means same or like, and this prefix hetero means different. You may remember these prefixes from your biology classes when you learned about homozygous alleles, which is when you have two of the same alleles, versus heterozygous alleles, where you have two different alleles. A homogeneous solution is going to be the same or uniform throughout the mixture. And a heterogeneous mixture is going to be different or not uniform throughout the mixture. So we have 6 examples below that we would be trying to identify as homogeneous or heterogeneous. Well, when we look at the fruit salad, inside of the fruit salad we see all different types of fruit, so we would classify this as heterogeneous. When we take a look at the apple juice, we see that the apple juice is the same throughout the whole bottle, so we would classify this as homogeneous. Gas is the same throughout, so we would classify that as homogeneous. In this pepper shaker, we see that there are different parts within the pepper in the shaker, so we would classify this as heterogeneous. Paint is a little bit of a tricky one. Because you have to stir paint, it means that it is not uniform throughout the whole thing, so we would classify paint as heterogeneous as well. And then lastly, air and the composition of air would be classified as homogeneous because it is the same throughout. So when we talk about those mixtures, we actually have a few more words that we can use to help classify different things as homogeneous or heterogeneous. And those 3 things that we're going to be talking about are going to be solutions, suspensions, and colloids. And so starting with solutions, solutions are going to be made up of very small particles that are going to completely mix into the solvent that they're being dissolved in. And we can really, when we think of solutions, we can really think about it as being synonymous to a homogeneous mixture. So we can really use those 2 words interchangeably. And because the particles are so small, these solutions are not going to separate, meaning that they're not going to separate into individual layers that we can see. On the other hand, when we talk about suspensions, so suspensions are going to be a type of heterogeneous mixture. They're going to have very large particles. And remember, in chemistry, very large is kind of relative. They could still, in our mind's eye, be small, but still be considered large. And because they are made up of very large particles, these do separate we can see them separate into different layers or different parts. And so that's going to be one key thing for us to understand when we're talking about suspensions, is that we're going to be looking for things that we can separate very easily, that we can see different components of. And the last one is what we're going to call a colloid. So colloids is also a type of heterogeneous mixture. These mixtures are going to be made up of like medium-sized particles. So they're going to be bigger particles than what we're going to see in a solution, but not quite as large as what we're going to see in a suspension. And because they're not as big as the particles that make up suspensions, these mixtures also do not separate. But they're going to appear a little bit more cloudy or a little bit less see-through than what we are going to see with solutions, because the particle sizes is going to be larger. So the Tyndall effect is something that we're going to be seeing when we're looking at our colloids. And this is going to be one test for you to identify whether or not you have a colloid. And what a Tyndall effect is the idea that when you shine a light through different mixtures, what happens to the light as it gets shown through the mixtures could be an indicator of what type of mixture you're looking at. So if we look at the image up here at the top, we see a laser beam being passed through two solutions. So we see, two mixtures. So we see it being passed through pure water by itself, and what we see is that as it moves through the water, that laser beam kind of disappears. We don't really see the light moving through it. But when we see it come into the colloid solution with the medium-sized particles, we see that that light is going to scatter. And we can see that that laser beam is moving through that mixture. So as it's moving through the mixture, we see that the particles cause the light beam to scatter, making it visible to us. And we can see the same thing happening down in the image here, where we've got a solution on the left-hand side and a colloid on the right-hand side, and we see that light beam scattering, and we're assuming that the light is originating from over here. So the last thing we're going to do today is practice classifying things as solutions, suspensions, and colloids. Remember when we were looking at the difference between homogeneous mixtures and heterogeneous mixtures, we classified apple juice as a homogeneous mixture, and homogeneous mixture is another way of saying solution. So apple juice would be a solution. Both muddy water and freshly squeezed orange juice with pulp would be examples of suspensions. Remember, in suspensions, we have large particles that are going to settle over time. So if we put muddy water or we put freshly squeezed orange juice into a glass, that is going to cause the mud or the pulp to eventually fall to the bottom of the glass and separate out of the solution. These last three are all examples of colloids. If we think about the fog example, if you've ever been driving and it's been foggy out and you turn your headlights on, you start to see the headlights kind of scattered from the fog. Remember, that is the Tyndall effect. So that is why fog is classified as a colloid. Milk and mayonnaise are going to be classified as colloids because they are made up of medium-sized particles. That is part of the reason that they are opaque. Remember, opaque means that we are not able to see through it. So those medium-sized particles contribute to that opaqueness, and because they are composed of medium-sized particles that do not separate from the solution, that is why we classify them as colloids.